In this video, I'm asking a question. Is there a golden eyepiece? And I will try to answer this by referring to my own experience. There are many eyepieces available. You can get as little as 1.6 millimeter Vixen HR to 70-80 degrees, some of the very rare eyepieces. They are 3 inches. But for the normal eyepieces that we use in the amateur telescopes, we use either 1 1/4 or 2 inches. There were 0.96 inches, called Japanese standard eyepieces. But they're getting rarer and people don't use them as much as they used to be. They were kind of, in the time has passed. So 1 1/4 eyepieces and 2-inch eyepieces. These are the most common eyepieces used by the amateurs. They're widely available. You can buy them as cheap as you like or as expensive and costly as you like. In my experience, in these two categories, there are zones or areas that we have the best possible image combined with the widest field of view available, free of all kind of or most of the aberrations. Aberrations means the errors or distortions you see in the field of view of an eyepiece. So this can be things like astigmatism, curvature of the field curvature, shift of the focus from the center to the edge of the eyepiece, and chromatic aberration, which is famous. Is the colors you will see when you are looking at an object, like colors of rainbow. In my experience, a range of eyepieces that you will have always have the central part of it clearer than the outer parts, no matter how expensive they are, as expensive as this 21 millimeter Ethos 100 degree eyepiece, which costs you as much as a fridge, a big fridge, 2-door American style as you call it, and or as cheap as any eyepiece that you want. For example, this 20 millimeter Skywatcher eyepiece, which is a kind of like a Kellner almost. The center of the field of view is always the clearest, and when you go away from the center, you introduce more of this kind of distortions of the shapes of the objects. In the night sky, we mean the stars. You see the stars which look like seagulls, they have wings as if, or they're stretched like a pair or droplets, and or the center of the field of view is different in focus than the when you're away from the center of the field of view. In an eyepiece like a Televue Ethos, they claim they have tried to correct this, and the same with the APM 20 millimeter eyepiece, 100 degree eyepieces. What I notice is that the maximum aberration-free area that you can achieve exists in a range from the 20 millimeter to 26 millimeter eyepieces. If you go beyond that, you are increasing the aberrations when you move away from the center of the field of view. So the optimum aberration-free area of your eyepieces are in the range of the 20 to 26. When you go for something like a 19 millimeter, the aberrations you expect to be less, like this Ostara eyepiece, or like this Takahashi 18 millimeter, or like this, you know it by the different names. This is a Star Wave 18 millimeter. So practically you're increasing the area available to the eye, which is clear of aberration when you're using this kind of lower power eyepieces. At the same time, because you're increasing the magnification with the lower focal length, you increase the contrast between the star and the background of the sky. So in the 2-inch eyepieces, I found that manufacturers actually have used this kind of thing. You see it, this is experience, you use them on the field, but the manufacturers build it based on that. So you see 20 millimeter 100-degree eyepieces, HTC, or 21 millimeter Televue Ethos. Hyperion 21, 24, they're very good. This is excellent 22 millimeter, one of the best eyepieces you can have, aberration free almost. And then you come to this gem of the eyepieces, Maxvision or Explore Scientific, or the Meade Series 4000 or 5000 82-degree eyepieces, 24 millimeter. These are the gems. They are the best aberration free. They give you that central part which is aberration free. If you want something with a bigger focal length, you include all those aberrations which exist near the margin of the field of view. So they give you that central part. The same here, when you use something as cheap as this, probably £5 or something like that, $10, £5, £7, something like that, depending where you buy it. This is rare, of course, super 20 millimeter. This is a Skywatcher one. So you're using that central part which is aberration free. This Silvertop Celestron, which is now this one, is a generic clone of it. Then you come to the 23 millimeter one, 62 degrees SVBony Aspheric, which is one of the best eyepieces you can have for telescopes with a focal ratio of 7 and higher. Then you come to this beautiful gem Televue Panoptic 1¼ inch eyepiece. Gives you widest field of view possible with a 1¼ field, 1¼ millimeter eyepiece. It gives 68 degrees of aberration free, most of it. As you go a little bit higher, the aberration increases. So when you are in the 23 and 20 millimeter, your aberration is completely probably gone. But yet we have a good part of the field of view in this Skywatcher Super 25 millimeter eyepiece, cheap eyepiece. It comes with usually with the telescopes free. The same can be told about the Meade 25 millimeter multi-coated eyepiece. Celestron E-Lux is one of the good ones, 25 millimeter. Again, it gives you that central part which is aberration free. And then we come to the Celestron 26 millimeter. This is a gem. Is comparable in a way to, you can say that RKE Edmond Scientific. And then 26 millimeter Plössl again, so Super Plössl as the Meade calls it, 26 millimeter lunar planetary LP. I don't know what LP here means. I should not say lunar planetary probably. Anyway, this is a Meade. It used to come with the telescopes that Meade provided, and they will come as included in the kit. So in this range, if you choose any eyepiece, there will be the maximum field of view, maximum area of the aberration free field of view, and what I should call it, a golden eyepiece. This is the golden range from 20 millimeter in the two inch eyepieces, from 20 millimeter to 24 millimeter. You have the golden range of the eyepieces, which are mostly aberration free. The 70 millimeter one is perfect in my experience. Then come the rest. Then after that, I believe this is this one. And this one, of course, this has a little bit less clarity than the other ones. I have a video about that, comparing it with other eyepieces in this range. Then we come with a 21mm or 20mm HTC. I prefer this one to this one, but anyway, it's personal choice. You may be thinking different. And again, in this range, 1¼ inch, from 20mm to 26mm, you get the widest field of view, aberration free of any kind of distortion. You can have a good look at the whole field of view and enjoy a sharp, error free, color free, most of the time, depending on the telescope, of course, you use eyepiece and image that the eyepiece provides to you. So this is my assessment based on my experience, based on actually what is also the manufacturers have realized they can produce aberration free. You can have something 82 degrees eyepiece in the range of 26mm or 31mm Nagler, for example, type 5. But then again, you're going either with a very chunkier eyepiece, the weight is increased, the length of the field, the length of the eyepiece is increased. So you have to make compromises, because the field of view will have aberration. When you want to correct it, you have to do a lot of expensive, additions and modifications to that increase the range of the price of the eyepiece. So that's the reason with the kit that you buy. When you buy a telescope, the kit which comes with it usually contains 25mm eyepieces, then goes 10mm and or 9mm. Usually 2 eyepieces they have. And there is a reason for that. The manufacturer knows that you get the best view with that. Of course, we later may choose to go for wider field of view, higher f numbers for the focal length for the eyepiece, and we use them as a finder eyepiece, as I call it. But these are the eyepieces that you will use most of the time. A finder eyepiece, if you use it, the image will be washed out with the light. For example, a 40mm or 50mm, most of the time it also includes all the skylight background, can be pollution or anything, and it will come all of that with the increased area that you're watching the image. It will all come to you. So the less contrast between the bright object that you want to see, a galaxy or nebula, and the sky background, which equally looks as bright, so you will not see much difference. So discerning and identifying the objects, especially faint ones, will be difficult. So in this range, you can have the balance between the sky background and the light which comes from the sky background, and the full field of view available to you. So this is the eyepieces that you will use most of the time in your telescopes. Either it is 1¼ inch, and I recommend these ones, any of these are good, or 2-inch ones, which any of these are also good. Some of them are better. This one is the gem of it's a Skywatcher SWA 22mm 70 degrees eyepiece. Is a gem of eyepiece. If I can say there is a perfect eyepiece, is this one. Yes, and it's rare. You don't find it anymore, it seems. You find the 1713 yet in the market for sale. I don't know why they don't make it. It's as with the cars. When a car is so good, after a while they don't make it anymore, probably because it doesn't make economic sense to sell it at that price. Anyway, my recommendation is that if you want a finder eyepiece, or kind of eyepiece that you can use most of the times, you will see most telescope time in this range, you will not go wrong. These are the golden eyepieces. This is the golden focal length, 20mm to 26mm in the 1¼ and 20mm to 24mm in the 2-inch eyepieces. Golden eyepieces exist. These are the ones. That's the diamond. That's the jewel, crown jewel of that golden ring.